Hi, how you guys doing today? Today we're going to be talking a little bit about solving equations. Last week we talked about orders of operations and simplifying expressions, and today we're going to be talking about solving equations, which really is just isolating a variable, finding out what that variable represents related to the equation that it's in. Up here, if you guys will notice, I wrote down some steps for solving equations. The first step is when you can distribute, right? The next step will be simplify each side before you start isolating the variable. Then you're going to want to move whatever variable that you are working to one side. I prefer the left, but you want all variations of that variable on the same side. Then we'll isolate the variable using inverse operations. Look, I spelled inverse wrong. I put two V's in it, but I'm a math major, not an English major, so it's okay to have spelling mistakes. Using backwards PEMDAS. So we're going to be doing the opposite of what's being done to it to get it by itself. Now, you guys should have seen this before, but it's been a while since you did Algebra 1, so we're going to be patient about it. We're going to try a few practice problems just to show you what I mean. So if I have, get some ink going here. If I have 6n, let's make it, undo that a little bit. Let's start over. If I have oh my God. Sorry about that. I'm still learning how to use this tablet thing. It's crazy. So say I have 6 times the quantity n plus 5 equals 2. And I want to solve for the variable m. When we're solving an equation, really what we're saying is, what is this variable, this unknown, equal to? And in this case, we're talking about n. So our first step is going to be to distribute. If we can distribute something, we should. And so if I want to distribute here, I am going to distribute the 6 into each of these pieces. So I'm going to multiply 6 times n, and then I'm going to multiply 6 times 5. 6 times n is just going to give me 6n. 6 times 5, well, that's just plus 30, equals 2. Now, I haven't changed anything on this first side, so there's nothing I've done to it that I actually have to do to the other side of the equation yet. That's going to start to change now, right? Because now I have 6n plus 30, and the whole idea is to get n all by itself. Now, our next step says to simplify each side, but each side is as simplified as it can get. I cannot combine the 6n plus 30 because they're not like terms, and there's nothing to combine with the 2. So the next part says move variable to one side. Well, all of my n's are already on one side, so we don't have to do anything for step 3 in this circumstance either. So now it just says solve for or isolate variable using inverse operations, backwards PEMDAS, which means that I'm going to deal with anything that's added or subtracted to this n term before I deal with multiplication and division or exponents or parentheses, right? So my addition and subtraction is I have this plus 30 added to 6n. So I'm going to use its inverse. I'm going to use the opposite of plus 30 on both sides, which is minus 30. So I'm going to subtract 30 from both sides of the equal sign, right? And then I'm going to be left with 6n. 6n hasn't changed. 30 minus 30 is 0, which is what we wanted, right? Equals 2 minus 30, which is negative 28. So we're getting there, but our n still isn't isolated, right? We still have this 6 term multiplied to it, right? When you have something right up against a variable. It's being multiplied to it. So I need to do the opposite of multiplication, which is division, and I'm going to divide by 6. But I can't just divide this side by 6. I also have to divide this side by 6. I can do anything I want on each side of an equal sign as long as I do it on both sides. Otherwise, I'm changing the value. So let's go with a rainbow. So now my 6's, they cancel, right? Because 6 over 6 is just 1. So I'm just left with n. I only have one n, right? Equals negative 28 over 6. And you're thinking, hey, that looks pretty good. I know what n equals, but I cannot leave this in this form. I can understand if you don't want to reduce big fractions, but if you can tell that both parts of the fraction, the numerator and denominator, are divisible by 2, you got to at least divide them by 2. So 28 divided by 2 is, oops, so I can do this, is negative 14. 6 divided by 2 is 3. And so we get n equals negative 14 over 3. We can put a box around it because we'd be done. Last time I put a box around something, it made it all a nice box for me, but this time it's not. And that was a pretty simple solving of an equation. We're going to do one that's a little bit more complicated this time. A little bit more involved. What if we have 3 times the quantity 5 minus 3x divided by negative 4 equals negative 15, right? That is a 15. It's an ugly 15. I'm going to make that 5 prettier for you because I'm a giver. Not much prettier, huh? But you know it's negative 15. The next time I write it, it'll be prettier. We're going to follow the similar rules, right? First thing we're going to do is we're going to do our distribution, right? Oops, sorry about that. Let's make it big. Make it not that big, but we're going to distribute. Rule number 1, distribute. So I'm going to take my 3 and multiply it times 5. And then I'm going to take my 3 and multiply it times minus 3x. And then we're going to rewrite the equation. 3 times 5 is 15. 3 times negative 3x, well, that's negative 9x. We haven't done anything to the negative 4, so it's still divided by negative 4 equals negative 15. And if you remember, when you want to clear the denominator on a fraction, all you have to do is multiply by that denominator, right? We want to multiply both sides by the denominator. Our denominator is negative 4. So I want to multiply both sides by negative 4. I have to multiply both sides because what this does is it goes ahead and it clears out this denominator because negative 4 over negative 4 is just 1. And I am left with, sorry, punched a button. Go away. I don't know how to make the thing go away. I don't want to clear the whole canvas. I just want to clear that thing. So we're left with 15 minus 9x equals, well, negative 15 times negative 4 is positive 60. And now we have a solvable problem, right? A little bit more easily solvable. We have 15 added to that negative 9x. And so I'm going to go ahead and I am going to subtract 15 from both sides, right? We're doing backwards PEMDAS, so we want to do our addition and subtraction before the multiplication. So even though negative 9 is multiplied to x, we want to get rid of the 15 that's added to it first, right? This is 15 minus 15, so I'm going to be left down here with negative 9x equals, well, 60 minus 15 is just 45. And now all I have left, the only thing left on this x that we have is that negative 9 that's being multiplied to it. And so I'm going to go ahead and I'm going to divide both sides by negative 9. These will cancel out because it's just 1, and I have x, right? Because the x didn't cancel out. I didn't divide by an x. Equals 45 divided by negative 9. Well, that's just negative 5. When we're finished, we're going to put a box around it. You don't necessarily have to put a box around it because in Delta Math, there's no box. But you get the picture, right? So when we're solving for these, you want to use backwards PEMDAS to get to where you're going. The other thing I wanted to talk to you about were some of the special cases that we encounter when we're doing solving equations. And those are, let me clear this page for you. If I have something such as, let's do special cases first. Ooh, that got big. Special cases. 2 examples. If I have 1 plus 3c equals 5 times 1 minus c plus, say, 8c, right? And we want to solve this for c. So I'm going to go ahead and I'm going to follow the same rules as before. I'm going to distribute, right? There's nothing to distribute here, so I'm going to just rewrite this side. 1 plus 3c equals. And I'm going to distribute the 5 in here. 5 times 1 is 5. 5 times negative c is negative 5c plus 8c. Our next step was to simplify both sides, and I have these c's on this side that I can combine. So I'm going to, again, go ahead and let's change colors. 1 plus 3c equals 5. I have minus 5c plus 8c. Well, that's plus 3c. So I've done that. Now, the last thing that I wanted to do is I want to have all of the variables on one side. And I have 3c over here, and I have 3c over here. I'm going to move this one right here to the left, right? So I'm going to subtract 3c from both sides. And when I do that, I am left with 1 equals, these cancel, right? And these cancel. I'm left with 1 equals 5, and that is not a true statement, right? 1 does not equal 5. So in this case, we have no solution, right? If you are left with 2 numbers at the end that aren't equal to each other, we don't have a solution, right? We lost all our variables. So unless that came out 5 equals 5 or 1 equals 1, we have no solution. Our other special case is, say I have 40 minus 8x equals negative 8 times x minus 5, right? Following our rule, we're going to distribute first. So here I'm going to have 40 minus 8x. Ooh, that is looking ugly. Let's see if I can make that prettier. 40 minus 8x equals, we're going to distribute this negative 8 in. So I've got negative 8 times x is negative 8x. And then I have negative 8 times negative 5, which is positive 40, right? And we want to get, again, we want to simplify, but there's nothing to simplify. Each side is already simplified. So we want to get all our variables on one side. So I'm going to go ahead and I'm going to add 8x to both sides. And I'm going to be left with 40 equals 40, right? 8x minus 8x is 0, and minus 8x plus 8x is 0. So I'm left with 40 equals 40. So in this last situation, we had no solution. In this situation, all real numbers are our solution, right? Because anything that I make x in this is going to give me an equal solution. It's always going to be true, no matter what value I put in for x. So if they can't equal each other, we have no solution. But if we're left with two numbers and they do equal each other, our solution is all real numbers. Everything, for every value that we can make x, we're going to get a true statement. Another thing we want to talk about is proportions. Ooh, didn't mean to do that. So let me clear this out for you. So when we're talking about proportions, you guys have done proportions before when you've done percentages and things like that. When we're trying to, you guys have heard of it as cross multiplying proportions. If I have, say, 5 over 3 equals 2 over x plus 4, right? I don't know how I keep hitting that button. I'm just going to disable the buttons on my pen, right? If I have something like this, I can do what's called cross multiplying, right? If I have a fraction equal to a fraction, what I can do is I can put these together on one side, and then I can put these together on the other side. So I can go 5 times x plus 4 equals 2 times 3, right? And then we're just going to solve them like we would anything else, right? I'm going to go ahead and I'm going to start distribution, right? I'm going to go 5x plus 20 equals 2 times 3, which is 6. Now we're going to go back again and we're going to do our backwards PEMDAS. We're going to do the inverses. So the opposite of plus 20 is minus 20. So I'm going to subtract 20 from both sides. I'm going to be left with 5x equals, what is that, minus 14. And now the only thing I have left on this x is the 5 that's multiplied to it. So I'm going to divide by 5 here. And I'm going to divide by 5 here. These will cancel out, and I'll have x equals minus 14 over 5. And that's how you're going to do proportions. Sometimes you'll have something complex like the x plus 4 on the bottom of both of them, and then you're just going to have to distribute on both sides. But that's all I'm going to go over for proportions. This is the part, though, that I think you're going to struggle with the most. If you do struggle at all on any of this, this is the part that messes most of you up. And that is when we're talking about literal equations, right? And I don't know how I keep doing that. Literal equations mean that you'll probably have more than one variable. A lot of times they're formulas, and you just have to solve for one specific variable. So if I have something like c over 2r equals 2 pi r over 2r, well, that's convenient. And I'm asked to solve for a specific variable. So if it says solve for pi, I want to get pi all by itself. That's the variable I'm solving for. My steps are going to be the same as if all of these other letters, these other variables, were numbers. But the idea is to get pi by itself. We want something that says pi equals, right? So the first thing I'm going to do is, there's nothing to distribute and there's nothing to simplify here, right? Everything's pretty intact. So I'm going to start by deconstructing anything that's attached to pi right now. So the first thing I'm going to do is, I've got this 2r that's divided, right? So I'm going to multiply both sides by 2r. I'm going to do it in a different color. Fix that pi right there. I'm solving for pi, right? I'm going to do it in a different color so that you can see it's not part of the original equation. So I'm going to multiply both sides by 2r. Right? I'm going to multiply this side by 2r. Right? This is 2r over 2r, so it is going to cancel out. I'm going to be left with c on this side. This 2r is going to cancel out the other, right? And I'm going to be left with 2 pi r on this side, right? So I've eliminated our denominator at this point. So now we've just got to take all of these things that are attached to the r off of it. And right now, well, what do I have? I have 2 and I have r attached to that pi. So I am going to, they're both multiplied, so I'm going to just divide by 2r and divide by 2r. Right? And this 2 is going to cancel, and this r is going to cancel. And I'm going to be left with c over 2r equals pi. Right? Now we might have been able to look at that at the original equation just because we knew those 2 r's were the same. But we still got to show our work, right? I guess you guys don't when you're doing it on, when you're getting multiple choice questions, but when you take a test, you're going to have to show me that you know how to do it. So let's look at a different one, because these can be kind of complex. So I want to make sure that you have more than one example. Let's look at A equals 1/2 AP. Now, this is for a triangle. This is for the area of a triangle. This is the formula for the area of the triangle. And what we're going to be solving for in this one is for P, right? We want that P isolated. We want it all by itself on one side. This P, we need to take everything off of it and move it to the other side so that we have P equals something. And the only thing happening here is, well, I have this fraction, this 1/2, so I can multiply times its opposite, right? If I multiply this times 2, if I multiply 1/2 times 2, 2 times 1/2 is just 1. So I'm going to multiply both sides by 2. Good form would have been for me to use a different color. So we'll go over it, and you can see red over top of it, so you can see that it's something I did after the fact, right? And here I would have 2a equals, and this 2 is going to cancel out my 1/2, so equals little a p. Now the only thing that I have left attached to this p is that little a that's multiplied to it. So I can just go ahead and divide both sides by a. And I'm going to be left with 2a over little a equals, these cancel, p. And I've solved for P. I've solved the literal equation. You are doing this when you're doing it with numbers all the time, right? The same steps are going to be followed. It's just now you've got all letters involved, right? And it'll really help you when you're working in formulas to be able to isolate whichever thing. Like say I have to multiply, find the area of something, and I need, or the length of something, and I have the width, and I have two lengths on one side, and I need to isolate all of that, right? It really helps to know what piece you want to get the solution for, right? And then you can just plug all the numbers in, the rest of it. It's just like solving an equation. But that's really all I have for you. And this is these solving equations. You're going to have a Delta Math assignment attached to it. So I'd really like you to make sure and get that done shortly after you watch this, so while it's still all fresh in your head. And I'll see you in class. Thanks.